Hello dear students, let's start our new module which is refraction through lenses. So we will start it with the definition of lens. So you can write a lens is a transparent refracting medium bounded by either two spherical surfaces or one surface spherical and other surface plane. So this is the definition of a lens. Okay, so in this, two surface can be spherical or at least one should be spherical. Okay, so this is the minimum condition of a lens, that both surface can be spherical but at least one has to be spherical. So further we can write it, lens can be classified as two kinds, in two kinds. The first one is concave lens and the second is convex lens. Okay, so let's discuss them one by one. About concave lens, concave lens, you are well aware about how concave lens look like. Concave, if I draw concave structure, this side will be concave. Okay, so this is concave, and let me show you convex also here. So this is convex. Okay, how you can learn? See, in this, it looks like a cave. In Hindi, you know it with as gufa. Okay, it looks like something like this. So you can remember it as it is concave, and the other one is obviously convex. So this is concave lens. So how it look like and how we can draw concave lens? Again, as per definition of lens, what we have seen here, that two surface should be spherical or at least one has to be. Okay, so with that definition we can draw concave lens as, let's draw, since it is concave lens, so one side must be concave. Okay, so this side we have drawn concave, so you can draw, this is concave side. Okay, now in this side you can also draw concave. Okay, so this is by concave lens. Okay, now you can also draw it as, since again we are talking about concave lens, so one side has to be concave and other can be, as per that definition, it can be spherical, or since this is the first condition, that first side should be spherical, this condition is fulfilled. And which type of a spherical? Since we are talking about concave lens, so we have drawn concave here. Other can be concave or convex and plane. We will see, first of all let's discuss plane. So this is plane, so what we will name it plano concave, plano concave lens. Okay, and the third type we can draw is, again I'm repeating that we are discussing about concave lens, so one side has to be concave and other side can, anything you can draw as per the definition we have discussed about lens. This side can be plane or this side can be spherical. Since one type of sphere we have drawn, plane we have also drawn. Now something which is left is convex side, so we can draw here convex side. So this side is convex. This is another type of lens. We will name it as convexo concave, convexo concave lens. Okay, so with that definition you can draw concave lens like this. Okay, so these three names you should keep in your mind. Now, let's further discuss about convex concave lens. We can write when the medium is rarer than concave lens will behave like diverging lens. Okay, please keep it in your mind. When the medium is rare, please focus on the word rarer. Means let's first draw here. It is a concave lens. Okay, it is a concave lens. And now, if the medium outside the lens is rarer, means this medium is rarer, then this concave lens will behave like diverging lens. Means if a parallel ray of beam we are drawing here is coming, what will happen? This concave lens will diverge this like this. Okay, so you can see the rays got diverged. Okay, so this is concave lens. Its behavior is diverging here. Now, one thing you should always keep in mind, which is the most important thing, that concave lens can also behave like converging lens. Students learn is as a thumb rule that concave lens is will always behave like diverging lens, which is always not true. See, the situation or condition for diverging nature should be that medium should be rarer. Okay, means you can write refractive index of lens should be greater than refractive index of medium. Okay, in that situation you can say concave lens will behave like diverging lens. Now again you can write if the medium is denser from the lens. If the medium is denser, then concave lens will behave like converging lens. Okay, so how the lens will behave depends on in which medium, or depends on refractive index of that medium, whether the refractive index of medium is greater than lens, or will it be greater smaller than lens. Okay, so you can draw here again, it is a concave lens, and if the surrounding medium is denser, if this medium is denser, then what will happen? If a parallel beam of ray is coming, then what will happen? It will converge. Okay, it will converge like this. Okay, so this is all about concave lens, how it behave, and in which medium we should place it so that it behave like respectively diverging and converging lens. Now let's discuss convex lens. Convex lens. You know that convex lens is the one in which the surface looks like this. This side is convex. Okay, so from the definition you again can draw convex lens like this. This side is convex, this side should be spherical. As let's draw convex first, so we will name it by convex lens. Okay, similarly, one surface should be spherical, and which type of spherical? Since we are talking about convex lens, then this surface has to be convex. And now from the definition you can make this surface plane, so we will call it as plano convex lens. Okay, and the third side is, since again I am repeating that we are discussing about convex lens, then one side has to be convex, this side is convex. And now from the definition you can draw it, this side can be spherical. Now first sphere we can draw means convex we have drawn over here, plane we have also discussed. Now this can be concave, so we will draw concave side. This side is convex, concave, and this side is obviously convex. Okay, so we will name it concavo convex lens. Okay, so this was all about how you can draw, how you can make convex lens. Now let's again, we have discussed what we have discussed about concave lens. Now discuss the same about convex lens. So you can write, when the medium is rarer than convex lens will behave like converging lens. Okay, so basically you can draw here also, if this is convex and the medium here is rarer than the lens, so what will happen if beam of ray is coming, then what will happen, it will behave like converging lens, it will converge the beam, means it will look like this. Okay, so this is convex lens and its function when it is placed in a rarer medium, means you can write refractive index of lens should be greater than that of medium. Okay, so this is the condition. Now again, what will happen when the medium is denser as compared to what, denser as compared to lens, then you can write, then convex lens will behave like diverging lens. Okay, so you can again draw it here. This is a convex lens and a beam of ray is coming here. Since the medium outside here is denser than the lens, so what will happen, the beam will diverge. Okay, so it will look like this, behave like this. You can write the refractive index of medium is greater than refractive index of lens. Similarly, you can write here also, mu medium is will be less than mu lens, and here mu medium will be greater than that of lens. Okay, so this is a condition. So this is all about concave and convex lens. So you, the main thing which we have seen in last few minutes, that it is not always true that the concave lens will always behave like diverging lens. It depends on refractive index of medium, whether it is greater than refractive index of lens or it is lesser. Okay, so this is all about this lecture. Next in next lecture we will see further discussion. Okay, so thank you so much for watching.